In this video, we're going to talk about applications of functions to economics. All right. And so our focus here is to learn about and introduce some economic terms and apply some algebra to those economic terms. We're going to first start with talking about cost, revenue, and profit. Um, your cost, we're going to use the variable expression or functional notation C of Q. So that means our input variable is Q and our output variable, our function name is C for cost. It gives the total cost of producing a product. You know, when you run a company, you make, let's say you make a cup or whatever, you have to pay for the material and the machines that's used to make the cup. And so those are usually involving our cost to that company. What we're going to do is we're going to first start by looking at what we call the linear cost function. And so since we only know about linear equations so far, we've only reviewed those. We're going to look at linear cost, and that's equal to fixed cost plus variable cost. All right. Now, in terms of a linear function, your fixed cost is the same thing as your vertical intercept. It's the cost of producing zero items. So even before you produce anything, it's kind of like your startup cost, your initial cost for your business venture. All right. That's your fixed cost. Your variable cost is going to be coming from the actual production of the items that you're creating, right? So fixed cost is kind of like your cost before production. And then your variable cost is the cost of producing items or units or whatever you have, right? And so the fixed costs again are going to be engulfed in your vertical intercept, and your variable cost is going to be engulfed in your slope times the quantity of items that you're producing. All right. Another term that we're going to talk about here is your marginal cost. That's the cost of producing one additional product. That is your rate of change. And since we're in the linear function case, we're talking about slope of the cost function, right? So it's your slope of your cost function, which is given in that equation as m, the cost of producing one additional product. Remember, your slope is your change in your output, which is here is your cost, for 1 unit change in your input and 1 unit change in your input, which is Q. Q represents your quantity of products, right? And so that's why the marginal cost is the same thing as your slope. Revenue gives the total amount of money that you make from actually selling a product. So cost is all about production and making the items. Revenue is all about selling the actual products. And so revenue always equals price times quantity. And we can use P times Q. This is also a linear function for us. Sometimes it won't be linear. Sometimes our price or our price can be modeled by a certain function. We'll see that later in the semester. But right now we have a linear revenue function, which is price times quantity. We also have marginal revenue. That's the revenue that's earned for selling one additional product. That is the rate of change of your revenue, which in this case is the same thing as your slope. And since we have quantity as our input variable, it's given by P in our revenue equation there. All right. And then last but not least, we have profit. Profit, we use the variable pi of Q. Our input variable is Q. We call our function pi instead of using P because we already use P for price. So we use pi of Q. It gives the total profit of producing and selling, right? So not only does a company have to produce items, but they have to sell the items. And the amount of money that they bring in on top of the sales or after accounting for the production cost, the cost to them, that is your profit. And so profit actually equals your revenue function minus your cost function. Here it is in math notation here. And just like we have marginal cost and marginal revenue, which were the rate of change of cost and revenue, we also have the marginal profit, which is your rate of change of your profit function. All right. And so let's look at an example where we apply these concepts. Example 1, a company producing jigsaw puzzles has fixed costs of $6,000 and variable costs of $2 per puzzle. The company sells the puzzles for $5 each. Find formulas for the cost function, the revenue function, and the profit function. Let's start with cost first. So my cost function is always going to be my fixed cost plus my variable cost, right? Well, it tells me that my fixed costs are $6,000 and I have variable costs of $2 per puzzle that I sell. And so my cost function, which is given by C of Q, I'm actually going to make my print a little bigger, thicker. I'm going to say C of Q equals my fixed cost, which is $6,000, plus $2 for every item that I sell. So that's going to be $2, and I have multiplied by the number or the quantity of items that I'm going to sell. So I get 6,000 plus 2Q. My revenue function, revenue equals, remember, price times quantity. And so revenue is R of Q. I sell for $5 each. So my selling price is $5 per item. I multiply by the number of items that I sell, which will be Q, which I can calculate my revenue by multiplying those together. I get that right there. And so now I can find my profit function. Once you know cost and revenue, you can calculate profit, because remember, profit is revenue minus cost. And my revenue function is 5Q. My cost function is 6,000 plus 2Q. Now, I'm not going to leave it like that. That's a Q, by the way. I'm going to put it in parentheses because I have to subtract both of those terms. So I distribute the negative there and there. So that's minus a 2Q. And so what I get here, 5Q minus 2Q is 3Q minus 6,000. And that is my profit function. Part B, find the marginal cost, marginal revenue, and marginal profit. And we're going to go over the units here. All right. So my marginal cost is the cost of producing one additional item, right? Well, that is related to the slope, because marginal is rate of change. I have linear functions. It is the slope. And if I look at my cost function, my slope is 2. Now, we got to think about what our units are. The units of this is your output variable. Our output variable is your cost. So the units of your output is, so cost is in dollars. And my input is Q, which is the quantity of items. And since we have puzzles here, it's going to be $2 per puzzle. All right. My marginal revenue. Again, marginal means rate of change. It's the revenue earned from selling one additional item. That's how I can interpret that. The value, since we're in linear functions, is 5. It is your slope. Our output is revenue, which is in dollars. My input is Q, which is the quantity of puzzles. So it's dollars per puzzle. And then last but not least, my marginal profit. Well, my profit function is also linear. And so since marginal represents a rate of change, since my rate of change in a linear function is the slope, I find that the slope is 3. My output variable is profit, which is in dollars. So it's going to be $3. And then I divide that by my input variable, which is the puzzles, because we have our quantity. So dollars per puzzle. All right, that's my marginal information. I'm going to do part C and D together. It says sketch the graph of R of Q and C of Q on the same axis, which is given below. Use a calculator to help, and find a point of intersection and state what it represents. So remember, we have R of Q equals 5Q, and then C of Q equals 6,000 plus 2Q. 6,000 plus 2Q, right? These are both linear equations. Y equals mx plus b. They can be written in that form, right? This has a slope of 5. This has a vertical intercept of 0. And then this one, I'm actually going to do a different color for my cost function. I wonder if I can change the color this way. No. All right. So I'm going to do my cost function in red here. That's 6,000 plus 2Q, if I'm not mistaken. Yes. All right, I know I switched the colors here, but I know that my vertical intercept for my green function, my revenue function, is 0, right? Because there's no plus b there. It's understood to be a plus 0, right? So I know it goes through this point here, and if I do my rise over run, I go up 5 and to the right 1. Oh, but my axes are counting by 1,000 and 5,000, right? All right, this is not very helpful. All right, my vertical intercept here is 6,000. So if this is 5,000, that's 10,000. 6,000 is somewhere over here. And my slope is 2, so I go up 2 units into the right one. That's hard to do here. And so what I'm going to do is I'm going to kind of go to part D here where I find a point of intersection, right? Remember, a point of intersection is a point where both graphs share the same input value and share the same output value, right? Now remember, your function equals the output value, right? And so if we're going to find a point of intersection, these C of Q and R of Q have to be equal to each other. And so if they have to be equal to each other and I want to solve some equations, all I have to do to find my point of intersection is to set these two equal to each other and solve for Q, and then I can plug that Q back in and I can get the revenue or the cost of for my point of intersection, right? So let's subtract 2Q from both sides. I'm gonna get 3Q equals 6,000. Divide both sides by 3, I get Q equals 2,000, right? So my point of intersection happens when we have 2,000 puzzles, all right? Now I wanna know the revenue I earn for selling 2,000 puzzles, and I wanna know the cost I earn from cost for producing 2,000 puzzles, then all I have to do is go to either one of these equations. Now it doesn't matter which equation you use here, but I go to either one of those equations, I plug in 2,000 for Q. I'm just going to go to my revenue equation since it's a shorter equation. So I plug in 2,000 for Q, and I get 10,000, right? So I get the point of intersection, POI, as the point 2,000, 10,000. And so if I go to my graph, 2,000, go to the right 2,000 and up 10,000, I know that both of these lines pass through that point. And so I've already said that my revenue goes through the origin and it's got to pass through that point there. It's a slope of 5. I know that looks a little weird. Let's make this bigger. All right. And then my cost has a vertical intercept of 6,000 and it has to pass through that point. There we go right there. So this is C of Q and this is R of Q. R of Q has a steeper slope, which is 5. C of Q has a shorter slope, which is 2, right? And we have our point of intersection here. And that is our point of intersection. And that point is called your break even point. All right. Whenever cost equals revenue, you have your break even point. All right. I'm going to go back to our profit equation, right? Profit incorporates revenue and cost. Now, if revenue, which is here, equals cost, that means your profit will equal 0, right? When revenue equals cost, when I subtract something from itself, I always get 0, right? And so basically, if I look at my profit function, when Q equals 0, that means I'm not produced or sold any items. My profit is negative $6,000, right? That means I always start in the hole because I have fixed costs. And so what this break even point represents is the number of items I have to sell and to produce and sell in order to get out of the hole. All right. And so that's what our break even point is. It's the point where your revenue equals cost. So this is your break even point. And it's also the point where profit equals 0, right? You know the quantity on which you get out of the hole. You're no longer in the red once you sell that quantity of items. That's the importance of your break even point. Some other concepts we want to look at include supply and demand. All right. So supply and demand represents quantities, right? They are quantities, right? Supply is the quantity of products a seller or a manufacturer or some producer that is the quantity that they want to supply to the market of buyers, right? So say you own a business, you own a company, supply is how much you want to put out there for people to buy, all right? Demand is the quantity of products that buyers or consumers are willing to purchase. All right. And so we're going to look at what a supply curve and a demand curve look like. But one of the things I want to make a note about is that both supply and demand depend on the price of a product. All right. They both depend on the price of the product, right? Y always depends on X, right? When we think about functions, Y is a function of, another way that we can say that, depends on X, right? And when we graph them, we put on our horizontal axis X and on our vertical axis Y, right? So if supply and demand, which are quantities, depend on the price, then I should, so these are quantities, supply and demand are quantities, they depend on the price, P. And when I say Y depends on X, the thing that is dependent on is on your horizontal axis. So I should put price on my horizontal axis, and I should put my quantity supplied or my quantity demanded on my vertical axis. All right. Now, although that is the case, when we graph supply and demand as functions, we use the quantity on the horizontal axis. So we don't use what we normally do mathematically. We're going to put Q on this axis, and we're going to do the price on the vertical axis. All right. The reason why this is the case is because historically, economists originally took price to be dependent on, to be the dependent on your output variable. But that view has changed. But when you graph them, that graphical convention has not changed, right? We didn't switch the axes when we started thinking about supply and demand depending on price. All right. And so when we see these things, it may look, the graphs may look a little non-intuitive, but we will put price on the vertical axis and we will put quantity on the horizontal axis. All right. Your supply curve is an increasing function, right? As price increases, the price is on your vertical axis. As your price increases, as your price goes up, manufacturers want to supply more of a product. And that makes sense because, you know, I would rather put things on a shelf at a higher price, more things on the shelf at a higher price, than to put a bunch of stuff on the shelf at a lower price if I know I can get more, right? And so from a that is why that curve is increasing, because as price increases, so does the quantity of items that suppliers want to supply to the market. All right. The opposite happens with demand. As price increases, buyers want to buy less of a product, right? And so as price increases, all right. Now it looks weird here. Price is on this axis. Price increasing is going this way. Quantity actually decreases. Quantity decreasing, it goes this way. Price increases, goes this way. And if you look at the graph, it's a decreasing function. All right. It's kind of an opposite relationship. What we're going to be interested in is whether the prices should be adjusted any, right? So let's say we know supply, we know demand. Is the market going to push prices upward, or is the market going to push prices downward? Well, we can look at graphs of supply and demand curves, and we can analyze those graphs in order to help us figure that out. And one way to do that is to plot supply and demand on the same axis, which we have in this example here. So, are in the same coordinate plane. I'm going to draw a horizontal axis because it disappeared. Here we have our supply. Remember, supply is increasing. Demand starts with a D. It is the decreasing function, right? So whether I'm looking at a graph or a table or what have you, I know that the demand equation is going to have a negative slope, or it's going to be decreasing. And then supply is the other graph, all right? Well, when I put supply and demand on the same axis, they have a point of intersection also, right? This is their point of intersection. And this point of intersection here is called equilibrium, the equilibrium point, okay? So where revenue and cost intersect, we get the break-even point. Where supply and demand intersect, we get the equilibrium point. It is the point on which, I'm going to say on which, the market wants to settle. All right. There's a balance here. And this is it's going to be the price and quantity. So where they intersect, because our horizontal axis is our quantity, our vertical axis is our price per unit. It is the price and the quantity where our market wants to settle, right? So what I'm going to do here is I'm going to pick another price per unit. I'm going to call that P1, and I'm going to do another price per unit, which is P2. Now, equilibrium is this P star, right? That's the price the market wants to settle. At P1, this price is definitely higher than the price at which the market wants to settle, right? And at P1, I'm going to look at the point that on both of these curves that have P1 as a horizontal coordinate. That value and that value there. This is the supply curve, it's increasing. At P1, this is supply, right? This is the supply graph. Supply is a quantity, right? So the supply quantity is here, the demand quantity is here, all right? It looks like supply, there's more quantity supplied than the demand for that quantity, right? So at price 1, supply is greater than demand, all right? When there's more items on the market than people demand, we call that a surplus, all right? Since this price on which this occurs is larger than the price at equilibrium, the market will force prices down, all right? And this will happen when supply is greater than demand, all right? I'm going to use a different color for P2. P2 is this price here, all right? So I'm going to say at P2, all right, I'm going to find my supply curve. It looks like we have this quantity of items, and on my demand curve, we have this quantity of items, right? So this quantity, if I think about a number line, is definitely bigger than this quantity here. The one to the right is bigger, right? And this is the quantity demanded at a price of P2 per unit, and this is the quantity of items demanded at a price of P2 units, right? Dollars per unit. So here, demand is greater than supply. Okay. So when people want items, more items than there are on the shelves, we have a shortage. And since this P2 is below the price at equilibrium, the market will force prices up. All right. So this equilibrium and knowing different prices around that equilibrium will allow you to know when to increase or decrease prices, or whether the market will force prices upward or downward. And you can use this fact here of supply being greater than demand, or of demand being greater than supply. All right. And so here's an example here. It says find the equilibrium price and quantity if quantity supplied equals 3P minus 50 and quantity demanded is 100 minus 2P. Both of these are Q's. That's supply and that's demand. Equilibrium is the point of intersection, right? So if I have a Q here and a Q here, the point of intersection, their Q's are going to be exactly the same. And so I can take their expressions, set them equal to each other, and that'll allow me to solve for P here. So I'm going to add 2P to both sides and add 50 to both sides. I'm going to divide both sides by 5, and I get 30, right? So $30 per unit is going to be the price. And if I want to find the quantity, I go back and plug in the 30 into each of these equations. Either one of those equations, notice since the Q's are the same for that P, no matter which equation I plug it into, I'm going to get the same value. I'm going to plug it into this one. It looks easier to me. And so I'm going to say that Q is going to equal 100 minus 2 times 30, which is 40 items. Our units are products, right? So my equilibrium price and quantity is going to be $30 per unit for the price, and I need to have 40 units to be on display or to be sold. All right, that concludes this video. I'll see you during the next one.